Hello and welcome to this build tutorial for the Digital Bird balanced pan tilt head. All of the print files can be found on the Thingiverse website and all the software on the GitHub repository. You can buy kits for the non-plastic parts from the Digital Bird Shopify channel. And you can go either way on that. You can just buy a generic mainboard and find all the other parts yourself. Or I also supply kits that have every nut and bolt required to complete the system. The choice is yours. Okay, so if we have a quick look at the new balanced pan tilt head, we can see that we have a joystick on the top for controlling our position. We can pan left or right and we can tilt up or down using that joystick. On the front here we have an RJ45 port, which is for our focus motor or zoom motor, whichever you choose. If we bring it around to the side, you can see that we're using the same NP style batteries as the rest of the system. We have the small OLED display again, which shows us our battery capacity along with our ID for the PTZ system. If we keep coming round, we can see that we have the two buttons on here for our mount and dismount, 7.5 auxiliary or external power supply here. A couple of magnets here for mounting the small controller to that, just somewhere to keep it. And a screw for tightening or slackening the system onto the mount through these holes. The system uses a standard L bracket here. I would really like it if I could find an L bracket which is longer. The system, as you see at the moment, is fully balanced or fully balanceable in the tilt, which is the most important one. But you're kind of limited with these brackets because they only come about 120 millimeters long as a set. It would be nice if they did one that was maybe 150 millimeters long that would allow me to move the camera a little further out to get more of a balance. Now, I supply it in the kit with this L bracket, but I guess you could retrofit a longer Swiss plate to fit onto this side. It would then allow you to get a balance in the pan axis as well. It's not a deal breaker. I mean, the motor will happily hold the pan regardless of the weight of the system where it is. It would just be nice if the whole system were completely balanced. Now, with these new devices also comes version 4 of the software. If you remember in version 3, the last version, I added the ability for the system to store unless it automatically stores all its key points, which can be very useful if you want to walk away from your setup and come back to it 2 hours later, or have lunch and come back and have all your key points remembered. Unfortunately, if you take the system somewhere else, or you open it up another day and start it up on a completely different set, it can become a bit annoying that all these key points have been stored. So I've added a clear key points button onto the home menu as well for release 4. The big difference, or the big change for release 4, has been the inclusion of the jib into the system, so that all the parts of the system recognize that the jib is actually present. Okay, so this is the build process for the Digital Bird balanced pan tilt head. The best place to start is on the base, and this has been printed with 60% infill to keep some rigidity in it. Our first step, is to put this large bearing in here, which is a 6811 2RS bearing, 55 by 72 by 9mm thick. And you can see we've got a recess in the bottom of our base here, and that should just be a firm fit in there. Now, because this would have been printed face down like this, the usual is the case. I won't mention this again with the parts, but obviously there might be a little bit of spread where the plastic was printed on the base. So it's worth taking just a blade and just scratching around that top edge to remove any spread that may have been involved and any noggins of plastic that are inside there. Then we can take our bearing, and it should be a nice, comfortable press fit into there, and press it all the way down until it fits all the way in. Okay. Our next step will be to take our printed cogs. Now this one is for the pan motor, the larger one, and you'll find also in the print list a smaller one, and this is for the tilt motor. So the larger one's for the pan, and it actually comes as two parts, this cap piece here and the toothed part of the gear is a separate part. And basically put an M5 bolt through the middle, bring the two halves together with some super glue in the middle, and you get a nice solid GT2 gear. Now the design is a little different from previous designs in that I've decided to put a tooth in here, so we no longer need these grub screws going through the plastic, which the plastic inevitably buckles over time, especially if there's any stress on it. So I've put these teeth in here. And if we look at our pan wheel, sorry, that's the tilt wheel, the pan wheel being the one with the holes in the side, you can see that the same toothing is in the top of that. So this gear will screw onto here and screw down. So before we actually go to fitting any of that, if we look at this pan wheel itself, it is printed at 100%, and it really needs to be 100%. It's carrying all the loads of everything above it, your camera equipment and the weight of the pan tilt head itself through this wheel. So this pan wheel has already been had the inserts put into it, but we have a is it 5/8 to 3/8 camera screw adapter thread, which, if you've seen any of the other projects, we use a hot, perhaps a blowtorch, much like this one, which is used for creme brulees, etc. in the kitchen. A pair of pliers just to heat this up and press it home and make it flush. Now, below that, you'll find that there is another cut for this bolt here, which is a cap head bolt, and if I can remember the size of that bolt, I've got it written down somewhere. Yeah, it's 45mm long. So from the base of the head to the end of the bolt is 45mm. That goes inside there, and that goes up. We take our base, and the pan wheel should fit snugly inside that bearing until it's all the way up like so. Okay. Now we can take our cog we mentioned previously, and that goes onto here, screws down, and probably need to hold that with an Allen key while we just screw this on. And once it's past the thread, we can see that that cog will fit in there and press down all the way. And we can just push that all the way up. Our next step then is to take our 200mm GT2 timing belt. This is 200mm closed loop timing belt, and that just gets placed around here like so. Next step is to take this piece, okay, and this is going to support our motor in here, our NEMA 17 motor. It's going to drop down inside here, that way. And in here as well, we have another 5x16 by 5mm bearing, which goes into the top. In this piece, you notice that there are a raised lip around the bottom. That goes down, and it should go into the same shape in the top of the base here. So that needs to go over here, like like so. Make sure we can still see our belt in that window. And it's not catching underneath. And that should just press together. Press down like so. Now we can take our 40mm long NEMA 17, that's 40mm in depth, with our 20-tooth cog on the bottom here. And you can see how the cog is mounted, with the base part, the thicker part of the cog at the bottom, and the main part of the cog closer to the top. Keep the output, if it's the style of motor with the plug on it or a cable, keep the cable to the back of the, there we go, keep it to the back of the pan tilt head. Take your cog and you should find you can just place it in like so and over the top of the belt, which is in there, and bring that belt down. Now, we've also created a small window here, and with a screwdriver you can just ease that belt over the top of that cog as it goes down into place. Okay. So next we take the second part of this and we can place that over here and let that drop down. Okay, so to keep that held together, if we turn it upside down, there are two holes. The first hole closest to the pan wheel is for a small 50mm low profile bolt. It's an M5 bolt and that goes through there and into the top piece. Okay, leave that loose at the moment. And while we're still on the base, if we take hold of our auxiliary power socket, this one here, what you really want to do is just put a little bit of super glue. I'll have the super glue ready. So that goes in this hole here. Push the cable through and bring it up, and just before you push it home, just add a little bit of super glue in around here to stop it from being pulled in and out. And then that should just pull through and be held in place like so. So that's for your 7.5 volt external power supply if you choose to use that. So coming on to this vertical piece, now I already have some of the parts put together on this. I'm not going to take them apart again, so I'll just explain what I've done. So up here we have two 30 by 42 by 7 bearings for our tilt motor, one on the inside here and one on the outside, and they just press home the same as the pan bearing did. We have our shutter release jack, and that's just a little bit of super glue again, push that through and bring the cable out through here, that's the blue one. Our rocker switch for our power supply, and that comes out with the black cable. Now inside here you see this little C that's holding the cables in place, that comes as a separate part. So push the cables through and then just super glue that C into the predefined holes that are in the side of this part for that. And that just keeps these cables out of the way of the timing belt, which is going to run in a loop around here. Below here we've got two small switches, and those are for our mount and dismount switches. Now this gunk here, you won't require that. Since I created this part, I've now put a hook in here so that you can just hook the cable into that. It'll keep it out of the way. My one has this ugly piece of chewing gum stuck in there at the moment. Now, I think that's that for the vertical part. So next thing is to bring these parts together. Now, they're extensions on the base of this vertical which go into the slots in the base. This one here and this bay here. And this area recess here is for this extension here. So to bring these together, just make sure that cable stays out of the way and doesn't get trapped. Oh, before I go any further, we need to take our NEMA 11, which is a geared NEMA 11, which is a 19:1 gearbox on it with a 20-tooth cog. And just note the distance, the direction that the cog is placed on the drive. It's a 6mm shaft on there, 6mm cog, and it's almost at the bottom there with the thin side of the cog closest to the motor. So with that ready and with the cables on that to the top, that should push like so into here. Okay, it's important you push that in, and you can see it coming through here on this side. It's much easier as well if you put the cog on the motor before you press it in. It's harder to muck around with Allen keys in such a tight space in here. Okay, so that goes in like so. I think that was, these steppers come with cables attached, not with a plug-in type cable. And I think it's 230, I'll just do a quick check. Give you an idea how long to cut. Yeah, 230mm. So if you cut your NEMA 11 stepper cable to 230mm long, and in the kit you'll get a JST plug and some crimps to put a 4-pin crimp on there. And that's the colour combination with the steppers on line motor at least. You can see that with the raised area on the back of the plug, it goes green, black, blue, red. Green, black, blue, red. Right, so let's try and assemble this. So the vertical slots in here. And just as I say, make sure that that cable didn't get trapped, the one with the yellow end on it for the power. And that should come down quite easily into those slots. Okay. The stepper motor cable, if you see the small gap in here, that needs to go in there, so it's worth just pushing that through here. And it will come out underneath here, as will most of the other cables. Like so. Pull taut like that. The other cable that might be worth putting through just now is the stepper cable for the NEMA 17. And the stepper motor cable is quite distinctive. It has a different style plug. So that needs to come through this hole as well. Catch it in this bay here and push it up underneath. So it pulls out the top, and you can just plug that in to that stepper to keep it tidy. Okay, so with that done, if we turn it carefully over its side, we can put through another low profile bolt, which is time of 30mm long, into this hole here, which runs through into this vertical member and helps keep it in place. Okay. Take another 30mm low profile, and the hole in the back here, that goes into here. And that's going to tie the structure together to create these really strong box sections here. Okay, so that's tied together pretty well. So now we can take another two 30mm low profiles and those two holes here, one in each of these. And screw them down. To hold the pan shaft on here more securely, we have, in the kit this will be a locking, nylon locking nut, but for the moment I'm just putting a standard nut on there. Okay. Now we take our 50mm low profile bolt and that goes into this hole here on the furthest side. Put that in and screw it up. And this is going to tension our belt by pushing this motor back until the belt becomes tense. And you'll see as we screw in that this motor will start to move back. There we go. And you can check inside the window here how tense that belt is. I'll go back a little further, and generally speaking it should be, yeah, that's pretty tense. And have a look at the cog for the tilt head. Now the tilt head has effectively an M5 flat low profile bolt inside it, okay, that comes right through. I think it's 50mm. And then we have a 3/4 to quarter camera a screw adapter, which gets, using the heat method, we get that pressed into the face of that, and that's going to take our Swiss plate, Swiss clamp, and allow it to be fixed to the face of that. So you can use the torch method that I've shown on many other videos to heat that and then press it home. Or you can just use a soldering bolt. Particularly with this one, you can just use a soldering bolt and just put the soldering bolt in the center there and feel it going down, and then just press it all the way down until it's flush with the face of here. Either method works perfectly well for these small ones. The soldering bolt method doesn't really work well for this big one because there's just too much plastic, too much metal in there. It takes a long time for the soldering bolt to heat all that metal. So with that in place and with that pressed in, we're ready to put that through here. Okay. Take our small cog, and again that is two parts that need to be glued together. And again it's toothed, so that simply goes on there. And we'll take another nut and we put that on there. Before I go that far, just check. This is our second timing belt, which is a 360mm long closed loop timing belt. If we put that over here first, yeah, as I suspected, probably better to put that over here first. And around our motor cog. Like so. Bring it up. Okay, let's leave that like that. There we go. That's home. Take our nut M5 nut. Again, in the kit, it would be a locking nut. Just tighten that up in there real quick. Okay, so to create the belt tensioner for this tilt motor belt, you find there's a part which is just a small plastic block like so, with an M4 hole through the middle. You need two of these 10 by 4 by 4 bearings and some small washers. There are two very small washers required and one larger washer. So what we need to do first is put one of the small washers on our nut, on our bolt. Slide on both of our bearings, like so. Put another small washer on. And finish off with the large washer. Okay, and that's the combination there that's ready to become our tensioner. Now, just behind the belt at the top here, you see a slot, and there's a gap behind that. Now, you may very well need to dig that out, because there should be supports in there behind that cavity. That cavity is for this small block. So what happens is the small block goes in behind here, and it should slide in to that hole behind there, and you should see the hole in the block there. Our belt tensioner goes in and gets screwed into the hole in that block. Like so. Before you tighten it up, you should, once you've pushed it in far enough, you should be able to push that whole assembly, including the block, until your belt is tensioned. So what I'll do is I'll just put that screwdriver in there. Perhaps a flat blade would be better. Just going to use this. And just push it over until it's tensioned. You can see that the block, I don't know if you can see the block, but the block is sticking out slightly out of that hole now. So push that over until we're sure our belt is tensioned enough, and we can just tighten this up in that location. And that's our belt tensioned. So as we turn that, you can see our motor turning. There needs to be a fair bit of tension on here, otherwise, you know, for obvious reasons, it will slip. Okay, so that's a good show. So we have everything tidy here. I guess the next step really is to take our control board. So this is exactly the same control board we used on the over-the-top pan tilt head. I have made some modifications to it, however. I've put another socket here, the yellow one, for the external power supply, and it's kind of jiggity because it's over on one side. And on the back I've made a patch. Now what this patch is for is to measure the current coming from the battery port. With hindsight, I would have built these resistors into the original board, but for now, until I make changes, and I'm going to make future changes generally to the boards, it is just a patch. But this patch allows us to use this little OLED display, which we're going to be putting in shortly. Okay, so for now, for the time being, it's a patch, two resistors, a 330 ohm and a 220 ohm, I think it was. And it reads the current off the pin of the battery, and that's going to give us our battery voltage on this little OLED display. And the other thing it will give us is our ID for when we're using the system as a PTZ system. It will tell us what ID this device is set up as. Okay, so the board then fits in here, and we can see that the RJ45 port for the focus or zoom motor goes through the hole we can see here on this side. This comes down, and if we take two of the slightly longer M1.7 self-tapper screws, we can put one in each of the corners on this side. There's only space to put 2 bolts in, but that's generally enough. 2 screws in. So I'm going to put those in now. So there we are, we've got our board in. I've plugged our auxiliary power into the yellow port. We can plug our blue cable, which is our shutter release cable, in here. Let's keep it out of the way. This white 3-pin from the 2 switches on the side here goes in here. Just make sure all these pins are in and the JSTs, they haven't pushed out like that one did. We have our 2 stepper motor cables. So the first cable is for our tilt motor, which goes into the top one, which is step 1. And the second one from our pan motor, which goes into step 2. Okay, so these prongs are already in this board. So what I would say is I'd generally put a bit of hot glue just along the top of that now, just to hold that board in place and the cable in place. We have this orange gasket, orange in my case at least, and we need to put that over the top of there. And with 2 short 6mm long self-tappers, we can just screw through that to hold that in place against the battery bay. And a new feature, I guess, for this particular battery bay is the ability to lock the battery in place. Now I've done this because I want this device to be able to be mounted inverted, and if I don't have some sort of locking mechanism for this battery, then the battery will fall out when it becomes inverted, or it could potentially fall out when it becomes inverted. So this is our locking button, and the hole here, that button should simply just go into here, okay, and come through. And you can see that, and just make sure work that a bit until it's free inside that. Okay, and in the kit we need a small spring, don't know, about 8mm long, 4mm, 5mm in diameter, and that goes on the back of that button like so. And then we need a keeper, and there will be 2 slots either side of that. And what we're going to do is put that keeper over, put some super glue in the slots, like so, and our keeper part here with the hole in it for the other side of the spring. You should just be able to drop that on there and push that to connect with the slots. Like so. Until it's dried. Now this little window at the top here is for our OLED display. Now our OLED display goes in this way with the socket at the top, and we can see that it should be seen through that window on the top of the battery bay. And we have a strap that looks like this, another two 6mm self-tapper screws, and that should just connect into these holes and just strap that display in place. Like so. Okay, so our power cable is coming out here, and this is going to run from our battery. You have the same two or four little lugs on either side of here to put in place, and just check that your battery goes in and connects for you like so. It's pushing out. Yeah. Now you find that your battery won't be able to slide out until you press that button and release it. Okay. We can take our cable for our OLED, which I think is this one. I'm going to set that to the side a moment. Okay, so if we look at our top plate, we can see that we have a hole in it for our small joystick, which is a board mounted joystick like this. That simply goes on here, through the hole, and in this case I've got that coming out that way, but it might be coming out the bottom way like that. Take our joystick, this is a 5-pin on one end and a 4 on the other, so we take our 5-pin through here. Okay, so you can just snip the strap out that comes with this part. We need two of our magnets. They need to go into here, and they need to match your these are for the little digital bird display, and so they need to match the magnets or the north or the south poles on those ones, so they actually attract when you put them in. That's the only thing you have to watch out for. So these magnets should attract your controller. Okay, controller out of the way. So this can go in here. It should just slot in, and at the front it should connect. You make sure it's in all the way around. You should feel it snap down into the slot. There we go, all the way around. Now the other end of this cable needs to go through this hole here. Take that out of the way just now. So our joystick cable goes through this hole here. Okay. Okay, so this piece over, that should go under there, and it should drop down, like so. Then we take an M4 bolt, that goes through here, and tighten that all the way down. So we turn it all around here, and our joystick can now plug in to our joystick port in the back of here. Like so. Now our OLED display cable, that's going to go into this little 4-port behind the RJ45. Marked in code on the board, but we're not using it for that purpose in this case. Okay. And the last thing to go in here is our power supply cable, which goes on here. And plugs in. Do your best to tidy up these cables, and then bring that together like so. Cable out of the way. Okay. And then we need another 2 of these M4 bolts, one through the back of the battery bay like so. And then one through the top here. Take our battery. And we can just see on our OLED display there, I don't know if you can see it, it's telling us our battery is about 75, between 75 and 100%, and the ID is 0. And if we try here, we can see that our pan is tilt is working. And underneath here, our pan is working. Okay. Joystick button on here. Now, this under quick release plate is a good choice. There are others. Quarters through here. Tighten that up on there. Take our camera. Release the plate, slide it down, lock it in place. Voila. One last thing, almost forgot, is that we have a 50mm bolt which is used for tightening this onto our tripod, and that gets stored in here. Okay. Now to keep that held in there, we take another one of those little magnets like this one. Doesn't matter which way around it goes. I'll just take this off. And that little magnet just gets glued into that slot there. Okay, check our mount and dismount buttons. Job done.